Hi, I'm Dave Burton. I'm the Product Training Manager at Nuaire, and this video we'll be looking at some hints and tips on how to install MVHR systems and comply with the 2010 building regs. In October 2010, the building regulations, Part F in particular, changed quite dramatically, whereas ventilation is now more of a controlled service. Part F of the building regulations is the means of ventilation within a property, and one of the key changes in the 2010 building regs was the need to commission every ventilation system that's installed. Later on in the video, we'll be showing you exactly the process you need to go through and the instrumentation needed to comply with the building regs and commission a system.
Hi, my name is Stephen Smith. I'm the residential manager. Here at Nuaire, we have a dedicated design team of engineers that produce your drawings to comply with best practice using the latest 3D Revit technology. This means that we can take into consideration all the needs of a ventilation system, such as noise and system performance.
A critical part of the installation of an MVHR system is the ductwork. Any ducting that passes through an unheated space, such as a loft, must be insulated. This is for two reasons. Firstly, it increases the efficiency of the system, and secondly, it prevents condensation from forming on the outside and causing potential damage to the building. In applications such as apartments where it's necessary to run the ducting within the ceiling void, a critical element is to make sure that the ducting that runs to external is insulated, again for the same reasons, for energy efficiency and to prevent condensation on the outside of the duct and potentially damaging the building. When the need to insulate duct occurs, Nuaire recommends that the installation is carried out using its new thermal duct range. This ensures compliance with the current building regulations. Connections in ductwork should be made using a non-hardening acrylic duct sealant and a suitable tape. This is to prevent any air leakage which could affect the commission and the airflow of the system. A common issue when installing flat ductwork or rectangular ducting is its tendency to bow in the middle when connecting two pieces together. This can be overcome simply by using the correct ducting with guide vanes to hold it correctly. The use of flexible ducting is discouraged under the current version of the building regs due to its high resistive nature. The maximum amount of flexible duct you can use on any heat recovery system is 300 millimeters per leg. The current regulations also state that any ducting rising vertical carrying extract air to outside requires the use of a condensate trap. This is to prevent any moisture from forming inside the ductwork from dropping back down and getting back into the fan, causing damage. Nuaire's heat recovery systems are currently in the region of 95% efficient. A 95% efficient heat exchange block can produce a substantial amount of condensation. It's important that this condensation is taken away from the unit to prevent damage to the unit and to the building. One very important aspect of it is the use of a trap. The use of a waterless trap is very important in the installation of a heat recovery system for two reasons. One reason is to prevent smells from coming back up from the soil stack where the condensate pipework should be terminated. And another reason is because there's negative pressure within the fan. If the trap isn't present, it can stop the condensate from escaping the unit and actually build up inside the unit and cause damage to the building. When it comes to actually installing a heat recovery system, ensure that the wall it's going to be installed onto can support its weight. If the system is going to be installed on a plasterboard, make sure that you use a pattress at the background just to give that added strength. Manual boost switches are required in all the wet areas such as example as kitchen, bathroom, ensuite and utilities. Always use external terminations that are made specifically for mechanical ventilation. On a heat recovery system, it's very important that these external terminations are kept a minimum of 300 millimeters apart. This is to prevent the extract air from re-entering the building through the supply duct and causing condensation within the house. Once the system has been fully installed, it should then be commissioned to prove that the airflow rates achieve what's set out in Part F of the building regs. This is achieved by using a hooded anemometer. Commissioning is a combination of adjusting the speed of the fan and adjusting the position of the air valves in the ceilings. The ideal scenario is to have the fan running as slow as possible to prevent noise breakout, but still achieving the design duty from each valve. Once the design airflow rates have been met, it's important that the air valves are locked off in their commissioned state. All airflow readings should then be recorded in the commissioning certificate found at the back of the Domestic Ventilation Compliance Guide. We hope that you found this short video guide informative. For more information on Nuaire products, please visit www.nuaire.co.uk.